Hello everyone. In this video, we're going to start the discussion on Unit 4. And Unit 4, the topics would be energy, work, and power. In this video, however, we'll be focusing on work. So how do we define work in physics? So work is the product of force and displacement of an object in the direction of the applied force. So it's the product between force and displacement. However, it's very specific here that the displacement and force must be in the same direction. Okay, so we can write, so mathematically we can write that one as W F times cosine theta D, where F is the force, D is the distance, and W is work in joules. If you're wondering why do you have joules there, well, that is the standard unit of work as well as energy. So 1 Newton meter is just equivalent to 1 joule. So work essentially is related to energy in the sense that when work is done, energy is being transferred. So an example of which is that if I'm pushing something, if I'm gonna push a table, some of my energy is being transferred to that table in moving that table. So the quantity of work done in moving the table is given by that equation there, F cos theta D. And theta is the angle between the applied force and the direction of the displacement. So that is relatively important. Try to focus on the figure here. We have F, the force. However, the force applied is angled off with the displacement. Displacement is in the direction here. So that is your displacement. So if you can see, since by definition the force must be in the same direction of the displacement, so the work that corresponds to the in moving this object is just due to this particular force and this particular displacement. So if you can see the displacement, this particular part of the force is in the direction of your displacement. So work is done only if an object is moved in the same direction as the applied force. However, value of work can be negative. If you're wondering why it's negative, well, you're gonna focus here. So you have there cosine theta. So theta could change. So remember that just like in this particular diagram here, this particular diagram, the force, the application of the force is angled off with the displacement. So if you can remember your trig, so this coordinate system here, you can represent this one as your 0 degrees, 90 degrees, 180 degrees and 270 degrees and then 360 degrees, right? So this represents the angle. And in the first quadrant and the fourth quadrant, if you're gonna examine your cosine theta there, cosine theta is positive. So any angle here and here in the first and the fourth quadrant, cosine theta is positive. So positive for first and fourth quadrants. While if you're gonna go to quadrant 2 and quadrant 3, cosine theta on those quadrants are negative. So these are negative for 2 and 3. So second and third quadrants. While if we're gonna focus on the quadrantal angles, so these are your quadrantal angles, if you can remember. Cosine 0 degrees gives you positive 1, while cosine of 180 degrees, the answer is negative 1. So if F and the applied and the displacement, the applied force and the displacement are in the opposite direction, they're anti-parallel, you can expect that cosine theta there is negative 1 because cosine 180 degrees is negative 1. So work there is also negative. And then for cosine 90 degrees and cosine of 270 degrees, both will give you 0. So this tells you that if F and D are perpendicular, work is equal to 0. So automatically work is equal to 0. That means that the force applied on the object doesn't do work in displacing that object. So again, that is for angles 90 and 270. So you have there, or one way of saying is that they're perpendicular to each other. F and D are perpendicular to each other. So let's take some examples here. So in this video, I will just cover example 1 and example 2. So how much work is done when a person uses a force of 160 newtons to push a chair 4 meters across the floor? So that means that I have a chair, then I apply a particular force F that enables it to move at a certain displacement. So it moves at a certain displacement. So if I'm gonna write my given, I have there F, which is equal to 160 newtons, D of 4.0 meters, and theta is 0 degrees. It's 0 degrees because if you can see, they're in the same direction, F and D. So the angle between them is 0 degrees. So work done is F cosine theta D. So you have 160 cosine of 0 degrees times 4.0. So cosine of 0 is just not 0, but it's 1. So work done is 640 joules. Again, since F is in Newton and D is in meter, automatically work is given in joules. So that's the work done in moving the chair 4 meters across the floor. So let's take another example, example number 2. How much work is done when a person raises a 50 kilogram mass to a height of 4 meters? Well, you can think of this as your vertical distance D. So if you're gonna look close to this particular problem, if this is my object, remember that if you have an object, it is subjected to the force of gravity. Force of gravity is always directly downward, and the magnitude of the weight is given by the product of the mass and the acceleration due to gravity. So you have here 50 multiplied by 9.8, which gives you 490 newtons. So if you want to lift an object, remember that you need to overcome the weight of the object. So you could think of this as the minimum force. So the weight of the object is just the minimum force needed to lift an object. So therefore the applied force, which should be upward because I want to lift it, F must be equal to 490 newtons. Well, if you're asking, can I apply more than that? Yes, of course you can. But again, in this particular case, we just take the minimum force needed to lift the object. So again, we're lifting it up, and then this would be your D. It's also, the displacement is also moving up. So the given are the following. F must be 490 newtons. Again, that's the minimum force that I need to lift the object. And then D must be 4.0 meters. Again, that's my vertical displacement given by the height. And theta in this case is 0 degrees. Again, it's 0 degrees because if you can see the diagram, you're lifting it up, the direction of your force is also up. So angle is 0. So now work is F cos theta D. F is 490 cosine of 0 degrees, and then 4 meters. So work is equal to, again, cosine of 0 degrees is 1. So that would be 0.1960 joules, or in correct number of significant figures, that would be 2.0 times 10 to the power of 3 joules. So this is the minimum, this is the work done in lifting an object. So that's all for this video. We're going to continue the example number 3 and number 4 in the second video for unit 4. So see you.